With tons of delicious nachos loaded with your favorite toppings, Taco Bell's nacho.
Hello everybody. Let's see if I can find the right buttons here. Happy Wednesday. Hope you're doing well. Working on a midterm, right? See what we got on store next. Yeah, there we go. So we're only going to go about 6 to 8 or so. We're not going to cover lots of Chapter 11 here. I'm going to touch on a couple of the highlights. Again, it's getting a little bit advanced, but we want to get to the important stuff and just make you aware of some of these things that you can do. So that way, if you are working in C++ code and you see it, you're not like, what is that? So we're not going to necessarily exercise all of these features here. We do want to hit hard on inheritance. That's one of those core object-oriented programming concepts that we're definitely going to practice. But some of the other advanced stuff we'll mention, talk about it briefly. Just know that it's there and you can go look up more information about it if you need it. And then you'll have the rest of 8 to 10 or so to finish up that midterm. I think I've had a couple people turn it in already. But hopefully that'll get done tonight. And that one's out until, I think I said 10 a.m. tomorrow morning if you're a real late night person or you really just want to do it tomorrow early in the morning. It does have a 2-hour time limit on it. So from when you hit start, you've got 2 hours to hit the submit button. And then it's actually going to lock you out after that. So do pay attention to the clock on it. Let's see, I think I've got, let's see. As of earlier today, I'd gotten all the quizzes graded, so it looks like a couple more people turned in some of the Chapter 8, Chapter 10 ones. So I haven't had a chance to look at that yet. Yeah, 3 people so for the midterm, due tomorrow by 10 a.m. or so. So it means you have to start it before 10 a.m. right? Because it has the 2-hour time limit. Right? So if you're going to take it tomorrow morning, you got to start by 8 a.m. if you want the whole 2 hours on it before that ends on you. Okay, so plan accordingly there. And then in the syllabus, I had the next project starting this week, but I think I'm going to hold off a week on that because we still have Project 3 in the works. So that one is going to be due next week, right? So then when next week rolls around, we'll finish up our last individual project of the main projects section here for your grade. Let's take a look. Yeah, so initially I was thinking we'd do Project 4 tonight, but I'm going to hold off till next week because next week is when Project 3 is due. Then we'll have 2 weeks to get that one in, and then you'll have your final project I'll assign. If you want to get started before Thanksgiving, work on it over break, fantastic. If not, you'll still have the 2 weeks here to work on it before it's due. So you probably do want to get started and give yourself more than 2 weeks to work on it. And then this last night of class, usually we would have done final project presentations where you'd actually get up in front of everybody and present your final project. And we could all see what everyone did and ask questions about their approach and that sort of thing. But I've just got the time set aside for you guys to work on it. And then that final project will be due about 11:59. I guess I could take it to like 8 in the morning the next day. But for turnaround time, I'm supposed to have grades in within 48 hours of this last class meeting. So I definitely need time to review all those projects. Hopefully you've had a chance to meet some of your neighbors and say hi to each other, or I don't know if you're hanging out in Discord or whatever you guys use for chat. That's cool. This final project, typically we do in pairs or trios, but given this remote learning environment, I don't want to force it on anybody. So if you are interested, you can work with somebody in a pair. I'm going to make it a little smaller than we would have otherwise, so trio is not really a good fit for this size of a project. But if you guys are interested in working with a partner, that's totally optional, up to you guys. You can if you want. If you just want to do it individually, that's cool too. Again, just sort of that's a casualty of us being in this remote learning environment. So, usually we'd have time after class to get together and work on these things. So, to generate the maze, so it's just user input. I had given that link out to the NoopBot, I think it was NoopBot project. Let me take a look. So if you want one, you can go use theirs, just as like an example maze here. Oh, that's an assignment, isn't it? Let me figure out the right buttons here. Did I put that in, or maybe I just put that in Discord? Let me take a peek. Hopefully you guys got your coffee. Oh, no, I didn't put the link in there. I'm sorry. So there's a link in Discord. Let me find it here in our class channel. Let's see. I think I put it in there, didn't I? Yeah, Newtbots. Okay, so there's this Newtbot link you can go to, and you can give it a min size and a max size, and it's going to give you a maze here that is solvable. They use spaces and X's, and then they use A for start and B for end. I mean, it's probably easy enough for us to replace those, but if you want to grab that, then you can essentially, put this into Notepad. Actually, probably a better editor, like VS Code is probably better. Code. Yeah, Code's going to be a lot better for you here. But you could do it in Notepad too. It's not the end of the world if you do it in Notepad. But let me throw that one not there. Nope, hang on. I need a new file. New window. Is that going to do it for me? Yeah, okay. So I just don't want to open up any of the other junk I have open. All right. Yeah, thanks 404. There's the link for Discord if you didn't have it. A new file. Okay, so if you just paste that in here, okay, it's a little bit annoying to try and put all those on new lines, but you can. You just bump them all down one. Right, pretty much, you take out the comma, and you bump it down, take out the comma and bump it down. And depending on how you're getting your input, right, if you're doing it one letter at a time or one line at a time, you could then go replace some of these things. So those are the double parentheses, and then I would just do like a find and replace here. Oops. Hang on. Did I not zoom in? Where's my zoom? Whatever. So if you find and replace, you can like replace the quote mark and just get rid of it, replace it with nothing. And then you can replace the opening bracket with a nothing. Right? You can replace an ending bracket with a nothing. Then you can replace a comma with a nothing. Then you got this, right? And maybe you replace A with start, and then maybe you replace B with end. So now you've got this that you could then essentially paste into someone, like into your input. I think that's actually got one extra line there. Well, maybe not. Let's see, it's hard to tell. Yeah, okay, so that should all be lined up, yeah, right along the edges there. So like that should be enough for a maze input. You should be able to copy that in. Right, and then the user can navigate the maze from the starting position to the ending position, right, using the up, down, left, right commands, if you want. Or you can just make one up yourself, right? But the idea is they should be able to input any maze that you want. So I could input, say, here's a bunch of walls, and then here's a wall, a bunch of spaces, and wow, that was weird. Oh, it's trying to auto-suggest. Wall, wall, wall. No, that is terrible. Wall, space. Wall, this sort of thing. It's so annoying. And then maybe put a wall, a starting space, a wall, the ending space, and a wall. Like, you can just make up your own little maze. Like, it doesn't have to be anything super fancy. And remember, it doesn't have to have walls around the edges. It could just be open. We're supposed to make sure they don't jump out of bounds either direction, up, down, left, or right. That sort of thing. So you just make up your own if you want, but it should be open to the user to input any maze that they want. Right? So they input the maze as characters. Right, and then someone had a question, so I posted a link. There's if you were trying to use cin, remember cin doesn't work with spaces. It ignores spaces. Right, and actually it will stop if you're trying to enter an entire sentence. It'll stop. So you can either use getLine, or there's this cool thing you can say no skip white space, no skip WS for white space, and then it will get those spaces as an input. That's one option there. getLine, you might be more familiar with that one and want to use that as well. Either way is perfectly fine, whatever way you want to approach it. But what we want to do is build out that two-dimensional vector. So like if you getLine, you could do an entire line at a time, and then you hit enter, we can get that entire line and then loop through that string, taking one at a time to add to the vector. Well, lots of different options. I'm not too particular around which way you go about making that maze. Either way is okay with me. Whatever works for you. Right, so we input the maze, and then they get to navigate it. Right. Yeah. So like whoever hits run, they are inputting the maze and playing it themselves. We haven't really got to the point. We skipped over files in chapter 4, the basic files. We're going to get to that next week, where we could like write it out as a file, so that next time we run it, we could go read it from a file. There's libraries and things we could do to go and get this information from online, which would be really fun. But that's again a little bit beyond the scope of what we've been doing. I do this in my Python class because I think it's really cool, and you can really easily in Python go out and hit a URL and get this information and turn it into a maze, and that's pretty fun in Python, but it's a little bit more challenging in C++ for us. So, yeah, you can just, if you want inspiration, sure, just generate, hey, a max 10 by 10 maze every time, go for it. You can do that, and they'll give you a 10 by 10 maze. Just up to you. So those links are out in the Discord for you. So that maze class, right, has the public function that stores the 2D vector as the map and knows where the player currently is, and then we navigate the maze, we up, down, left, right using the public functions of the maze class. That way we can test it. So if I make maze and I set the vector and I give it here's all the information there. So and what that means is maze has no business with C in, C out. Right, the maze class. It should not do any C in, any C out. The class itself should be standalone in case we want it to be part of a web application, or want it to be part of a mobile application, or want it to be part of an actual graphical user interface. Right? The maze logic itself has nothing to do with input and output. So the way that you interact with it is you need a public method that you can do something with its size. Interact with the vector, set characters, whatever you're going to be doing, any approach you want there. You need a way to interact with the maze and tell it what the locations are. So like as we are asking the user to input the maze characters, this happens in the main method that does C and C out stuff, because main is pretty much telling us, hey, this is going to be a console application. Not entirely the true in this case, but for our purposes here, we're going to be interacting with it in main with C and C out, or getLine, whatever you want to use, right? That make sense? That's a good question. Cool. All right, so back to Visual Studio. Let's start a new empty project. So I don't want to put it in source repos. I want to put it in my class repository. There we go. And let's call this Chapter 11 Examples. Why not? So Chapter 11 is all about, we've done like the basic classes and talk about object-oriented programming, where our classes are anything that's a noun is a potential class. It doesn't have to be a class, right? But it could be. And we kind of want to evaluate that. You could go nuts and make every little thing a class, and you might not be gaining a whole lot out of that. It might just actually make things worse, right? Like if we're designing a tree class, if you want to make a class that represents the leaf, maybe that makes sense because leaves have colors, and in the fall the colors change and the leaves can fall and they can grow. So maybe it makes sense, or maybe it doesn't need to be. And that's one of the parts of programming that's an art. Right? It's a design idea that you have and how we're going to best represent those objects. So anything that is a noun could be a class. Let's include IOStream, namespace, standard, main, turn to 0. Okay, so we've got namespace. It'd help if I could spell things right. We got this. We're going to add a class here. And I'm going to do it all in the H file. Again, there's pluses and minuses. I like that it's testable all in the H file without having to do lots of other stuff. So we did classes. Right? We looked at the this pointer. We talked about the this implicit pointer already. So that was good. So we're going to write a class for, we'll just call it person. Right? And we have a private section and we have a public section. I know everything defaults to private, but again, it's just a good habit to have. Let's be explicit and say, okay, here's the private section, here's the public section. We're going to learn there's another section we can get here in a minute when we start talking about inheritance. Sorry, my department chair is texting me, and apparently we had an issue with Zoom in another instructor's class. Oh boy. Yeah, okay. Yeah, another reason Zoom is terrible. Oh boy. Anyway, so stuff that's private, right? The idea with object-oriented programming and design, we want to encapsulate all the details of this object in this class. So like it's a standalone class, has everything that it needs, and it protects its private variables. Make sure it has some integrity around that, right? Making sure when you give it values, we're not taking things that shouldn't happen, right? Like if we're I think do we do circle or something, that we have a positive radius. You can't have a circle with a negative radius. Those sort of sanity checks in our set methods. So typically we make things private, so we'll have a private string for, say, first name, and say a string for last name. So I think we need to include string, and using namespace standard. I think that ought to do it. Make the lights go away. Really? String. No. That's uppercase. Uppercase string. String. Wow. This is not going well already for me. String. My goodness. What did I do wrong? Is it lowercase? It is lowercase. Oh my goodness. Okay. Looked funny. Okay. We have a private string for first and last name, and if we want to give people access to those, right, we write a constructor that might return a string and like get first name, where we would then, I'm sorry, return, we don't need public again here, getting confused, return first name. Right, we might write a string for, outside of that, a string for get last name. Can't hit the right characters, and return last name. Okay. So this is pretty basic, right? Now, if we wanted someone to be able to change the first name and last name, we would write set methods, which are typically void methods. We'd have a set first name, which would take a string for first name. And this is where you have that this implicit pointer, right? I said I like this syntax. Other people hate it when you duplicate the name. I like that it's nice and wordy, right? And you know exactly what you're asking for here. I want a first name. So it's this pointer, first name, is the first name argument. So notice this one is gray and it matches the gray color. And notice this one is white and matches the white color here. That's just your little hint. And I think even Visual Studio is smart enough to say, hey, this is bad. Nope, I thought it would give us a warning. Maybe not. We do the same for last name, right? We can have a void set last name that takes a string for name, the last name, and my this last name is the last name. Right, we okay so far? Nothing new here, right? I'm just building on a class. Then we could add a constructor. I could say, okay, I want a person method. Now remember, constructors are special. They don't have return types. And maybe the constructor here takes a string for first name and a string for last name. String space, there we go. And then we could either call our set methods, we could set them directly, or we could use that initializer here. Either way you like, lots of options here. People are fond of all the different options here. Hey, Blowfish, thanks for coming by. All right, so this uses the member initializer function, or we could say my this first name equals the first name argument. First name, or I could even call my own set first name, given the first name, right? I'm fond of calling my own set functions. I mean, these ones are really dumb and boring and don't do anything, but if your set function has any sort of sanity checking, you don't want to do that twice. You want to just let your set function do that for you, and let it do the sanity checking, like make sure we didn't get a negative value or something, right? So lots of us. So these will all do the same thing here, essentially, right? Maybe I should copy that for last name. Or do you need all the redundancy? Why is that not? Oh, last name with a lowercase l. There we go. Casing matters. Okay, so still nothing new, right? But we're just building on a class. All right, now let's get crazy, okay? So we have the this pointer. We can use constant as a notation here, whether or not we're going to change the variable that's passed to us, or whether or not we return a variable if it should be changed. You can mark them as constant. It's a really nice safety thing to do. So if you don't want your name changed, you can say, hey, it's constant. Constant. Just so when it gets returned, it's immutable. So depending on what you need to do, you can add constants. That's nice. Classes can have static variables. And now static variables get a little bit silly. But the idea that what it is, so these are instance variables. Each and every person will have its own set of first and last name strings. There's nothing shared there. But maybe we wanted to have some sort of, I don't know, if we wanted to uniquely identify our people, I might have a static int for person number. So if I have a static variable, what happens now is this does not belong to each instance of person. Static is saying it belongs at the class level, so it's defined once for the class, and that's it. So we're going to start it off at 0. Oh no, that's right, I can't assign it here. That's right, I can use it after. That's fine. So let's have an int for ID number. We're going to have a private int for ID number. So we don't want people to set it. We just want it to be a get. So we're going to have a get ID number. We're going to return our ID number. And what we're going to do is when we make a person, I want to set it to the static person number. So each person gets a number, and we want to make sure it's unique. So I'm going to take my person number. I want to check. Oh man, what do I have to do that? That's annoying. So we're saying it's static. Yeah, how do we give it that value? That's all right. Okay. So we're going to take my ID number is equal to the person number, and we're going to add 1 to it. So person number plus plus. So we're going to take person number, we're going to add 1 to it, and we're going to use that as our ID number. So this is set once and shared among all instances of person. So over in source, let's see if we can make some people. So we need to include. Remember, that's in quotes now. Our header.h. Okay, maybe I should have called it person, but let's call it person. No, fine. Header h, because we're going to add more classes in a minute. Just say a person. Eric Chernesky. So I didn't use the new keyword, so I don't have a pointer. This is declared out here in the stack. And then let's see if we can see out Eric.get ID number. And then line. Let's see what we get. I think we need to set it first. Yeah, so we're going to set person. Oh, no. It is private. That's right. We can't set it there. That's silly. That's silly. Person ID number. Not be defined. Nope, not ID number. Person number. Int person number. That should start it off at 0. Yes, thank you, Blowfish. Tell it it's an int, set it to 0. That's silly. Okay, so now let's get our ID number. Let's see if we get that automatically assigned. Actually, let's make a couple people here. So let's make a Blowfish. As you're here and you're actually talking in class. So you're Blowfish Fugu? Is that a reference to The Simpsons? Is that what that is? Fugu, was that Am I remembering that right? Could totally be off. Let's see. So we should get two different numbers. Oh no. Any C++ tips are fun. We're trying to mostly stay along with the book, so it doesn't get into super complex topics typically. Oh, okay, it just means blowfish? Okay. All right, yep, so we get a 0 and we get a 1. So it doesn't look super exciting, but that's okay. So that static value then, it's shared. So, you know, some people love doing these. They definitely can have some really good purposes of having a static value that's shared among the classes. I tend to find these confusing. More interesting are static functions. So a static function does not have a this pointer. Because it's static, it belongs to the class level. So if there's something that you do at a class level that doesn't need to have instance attributes, it can be static. So let's add another class in here just for fun. Why not? Let's do that class for circle again here. So what we could do in circle is I could have a bunch of public methods here, and I'll make these static, and I'll call it a double, let's say get circumference. If you give it a double for radius, I'm going to calculate and return a circumference. So I don't need an instance of circle. So I'm not going to make a circle that has a fixed radius. I'm going to say, hey, if you want the circumference, if you give me a radius, I can calculate it. I don't need to have an instance of circle in memory with any sort of instance attributes. So we can return radius times, and we'll just do 3.14159, I think. Is that radius? Did I spell it wrong? Oh, yeah, I did spell it wrong. Radius. US, radius. And maybe I'll say this is approximate, because that's not super accurate for pi. But sure, so we could do that. We could have get circumference. How about a get diameter? Now that one probably not approximate, because that's just 2 times radius, which is really silly, but we can offer these sorts of functions, right? Those are helpful. How about get area? That one's a good approximate, right? That's pi r squared, right? So we'll just do radius times 3.4, 3.14159. Right, so do you see that these ones can be static methods because I don't need to have an instance. Now we could have a circle that has an instance attribute for radius that's stored. We can compute these things and then we could do stuff with them. But if it doesn't need any variables, it could just be a static function. And we've used a lot of these static functions before in our other classes. When we use some of the libraries here, we do a lot of stuff with the static ones. So then in here we could do a circle, right? So I'd say circle : get area approximate. Sure. And give it some radius. I don't know, so let's see out the approximate area of a circle with a radius of 4.2 is, right, and we can output that. So that's a static method. So it's not accessed through an instance, and I can't actually make a circle. Some circle. Maybe it'll actually let me. Yeah, okay, it'll let me, but like we don't do anything with some circle. Some circle. Right, some circle dot, and there's nothing to do with circle, right? There's no instance methods, instance functions with circle. So like having an instance of circle is silly. We don't ever use it that way. So we always go by the class. So this is the class level circle definition. And what's nice is these are going to be faster because it gets loaded once and it just runs. It doesn't need to keep anything in memory there, and you don't need more than one of them, that sort of thing. So maybe I did have circle as a class. Maybe we did have some instance attributes, each instance doesn't need its own version of solving these, right? Unless it's using its own radius as the attribute. We just keep things separate. So those are static member functions. Another fun thing you can do is you can declare things as friends. Friends gives another class access to your attributes. It's not anything we're going to play with, but just know you can declare things as friends. That can be helpful when you want to overload how you output yourself in the output stream with that extraction operator. I think that's called the extraction operator. So you can overload this operator so that you can send yourself to an output stream. It's in the numbers library. Yes. Yeah, I know there's a pi constant somewhere. I'm so glad that they finally have an official constant instead of letting all of us muck around with our own, but maybe that's part of the fun. What else is in that numbers library? Include numbers? Is it not even letting me? Not even give me numbers? What, am I on some old version? Oh man, that's fine, yeah. Do you actually use pi a lot, Blowfish? Curious. Like, is it actually that oftenly used? Oftenly? Is that a word? No Fortran. No. C++. Excuse me. All right. So some other interesting things we can do with classes, and this actually gets important here. You can overload a couple important operators. And in our case, I think we're fine with this one, person. Right? Oh, polar coordinates and stuff. Ooh. Okay. Yeah, I guess if you're doing anything math related in your application, you might anything trig related, not just math. All right, so we've got our person here, and now how about we have another class? Why not here? This will be fun, right? How about we write a class called parent, and the parent class, right? We're gonna have a private section and a public section. What if we wanted to have a list of people for children, right? I might have a person array called children. Didn't I give it a semicolon? Am I on the wrong side? I'm on the wrong side. Okay. And then what I might do in the parent constructor, I might take an int for number of children. And I'll say children equals a new. Oh. Yeah, children equals new, right? Person array, size of number of children. Oh, I don't have a default constructor. That's unfortunate. Really wanted to do that. Okay, so we're going to add a default constructor. It's unhappy with that because it can't make an array if it can't have a default constructor. So we'll just add a person constructor. This, we'll set first name equal blank and last name equal blank. Ah, that's okay. That's silly. We'll call our own person constructor here, right? And we'll hand it blank and blank. Because otherwise I have to do that ID number too. Okay, red lines went away. Good, 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 good. Okay, now it should be a little happy. Okay, now what is it not like this? So children, that has to be a person. This never works trying to do examples in person. So children. Making my pointer. Children. I'm failing here, guys. I'm sorry. Make it a single one, right? Single. Single. Give me the star. Okay. My goodness. Person pointer is an array using dynamic memory of person. All of this to set up a silly example here. Sure. Okay. So now you can have a bunch of children, given number of children. You can do some other cool operator overloading here. One of the operators we can overload, where's my example here, is the operator for index notation, index of. So I probably want to store that number of children, right? Number of children, that way I know what my size is. So then we'll set my this number of children equals to the number of children. Okay. So we want the operator, come on, operator. No, is it this one? I don't think I want the new. Where's my operator? Oh my goodness. Okay. This is going terrible, guys. I'm sorry. I'm sorry. This should have gone a little better. So I'm going to be able to set things for children based on their value. Let's just Google it. Let's just Google. Why not? C++ operator index overload. Oh, it's override, I guess. Oh, I don't want two. Yeah. Operator. Oh, because I have to return it. It has to be a type. So I can give you back a person if you give me an operator here that takes an int. Int index. Aha! Okay. If you get the syntax right, it's a little happier. So I'm going to use this index notation, and I'll give you back a person object here from my person list. So first I want to check and make sure that it actually exists. Right? So if index is greater than or equal to 0 and index is less than my number of children, I know it's a valid index. Right? I know it's valid, so I can return children at index. Right, so children is my dynamic array, right, with dynamic memory here. I can return that person object at that location. If not, maybe I just return, again, probably throw an exception, but we haven't really covered that yet, so I'll just return, say, person. We'll just give you back an empty person. I don't know, that's probably a bad thing to do, but that's okay. Sure. Should throw exception. Haven't done that. Maybe we should just do that, but we're running out of time already because we only have till 8 tonight. You still got to take your midterm. Okay, so I can overload an operator, get back a person. You good with me so far? It's not too crazy yet. So let's see if I can make a parent. Parent. Here, let's change. Okay. Actually, parents don't need names, do they? Right? Parent, and then parent just needs number of children. So we'll give parent 2 children, and I can say parent at what? At 0 dot. And here's where it's silly now, right? So parent at 0 dot. This is a person. Because we overloaded that operator to say, okay, the thing at index 0 I'm going to give you back. That's the person. Let's see if we can set the first name to Eric, and parent at 0. Let's set last name Charneski. See if we can add some more people here. Right, and we'll take parent at index 1. Set first name. Let's add Blowfish again. And parent at index 1. dot set last name. We'll just be redundant here, fugu. Okay. Now we probably want a get number of children in here too, right? So an int get number of children. Return number of children. And I could say, I don't know what, for index is 0. Index is less than parent.get number of children. Index plus plus. Oh, sorry, that looks, yeah, now it formatted it for me. Let's see out parent at index dot get first name, add a space, and I don't want to have to type all that again. Dot get last name. Oh, and a space, right? Let's bump this down one. And how about get ID number? Oops, that's a function call. Need some parentheses there. And we'll get the ID number. How about an end line? So we'll just loop through and get all the children. See if that works for us. And they should have IDs of 2 and 3, right? Because this was 1, this was 2. We made a new one for 3 and 4. See if it builds. Look at that, we didn't even get errors. 2 and 3. Oh, we didn't get any names. We set the name. Yeah, so what happened here is it looks like we're returning person here, but there's a couple other things that have to happen with our class. So our classes get when they get assigned and when they get returned, it's kind of funny. There's some different constructors we want. I'm trying to remember the right one here. Let's see. Yeah, so a copy constructor is how we make a copy of an object. So we're not returning a reference. We could just return the reference, right? Which is probably what we want to do here, because when I give you back this, it's actually making a copy. And it's hard to illustrate that, I think, with this return line. I don't think we're going to see that happen here in debug mode. Let's take a look and see if we can see it happen. If not, we'll write that constructor and I'll show you. When I go to return, I'm going to step in. Yeah, it doesn't show us at all. That's unfortunate. So we can see in parent, oh, that's the operator returned. In parent, here's children. They're still empty right now. So seeing here's the start of that memory address, right? At 1444. Yeah, I never saved it. Okay, so I'll have to show you here. So what happens when you return a value like that? We're actually making a copy because I'm not returning the reference. So over in person, what we would do is we want to define a copy constructor. What a copy constructor is, it's another overloaded constructor, person, and it takes a constant person reference. Some people, OBJ, I'm not a fan of object. Other maybe is common. Other people just call it person. I mean, sure, whatever you want to call it here. But it's a reference to another person. And it's going to make a copy of that here. So in the copy constructor, what C++ does for us is it defines one automatically, and it just takes all of these instance attributes and copies them. So we get a copy of all of these here in this version, which is sure. So we're going to say, because we need to return that person. Right, so it's expecting to get a person object given from this person. So I'm going to take my first name, and I'm going to set it to the person reference first name, because this is how you create a new person from this person that you were referenced. I'll take my last name is the person.last name. And now C++ is doing all this for us, right? By default, it'll take all these values and set them for us. I'll take my ID number equals the person's ID number. Okay, so that's the copy constructor. So if I put a breakpoint in here, and then we run, we're going to see this one gets triggered when I try and return that value, because I'm not returning a reference, I'm returning a copy. So I'm about to return a child, right? Children at index 0. Right? We can see this parent here has 2 children. There's actually not a whole lot going on in there, right? They're blank. And if we step in, now we get to this copy constructor. So we can see it now because we wrote it ourselves. Right? And we'll see, okay, so the other person was ID 2. Right? And it's just blank first name, last name. And now I'm going to go here, parent at 0, set last name. Let's step in. Not to that one, step out, step in. Okay, to the operator. Index is okay, right? We're still asking for index 0. Now we're going to return another child, right? This is the at index, a copy here. Not that one. Oh. So still ID number 2. We're making a copy of that one here. Okay, we return that person. I'm able to call set on those, but because I set the copy, they didn't actually change in parent. Because I had a copy, I didn't have a reference. So that's actually not doing a whole lot of good for me here, right? So what we want this to do is actually to give you back a reference. So this copy constructor is important to see. It's not as interesting here for person because these all copy nicely for us. Let's see. Yeah. Okay, good. But maybe we want to return a person reference. Can I say reference to a person? That doesn't. I do new person? No. Hold on. How do I get the reference here? Let's see. We'll just say person, and then we'll just return. We'll return that reference. Person. Return reference to person. Can't be initialized. Non-constant. Why is it so unhappy with us? Why is it so unhappy? There's a new person. Person pointer. Dereferenced person. I mean, we don't actually want this to work. We should just throw the exception instead of doing this. This is silly here. This is just bad. Yeah. All right. This was just ugly. So if that's not valid there, we're going to throw an exception. And you know, I always just go Google because it's easier to Google than to go find it in the textbook. Throw exception. Come on, give me something good. Yes, just throw. Okay, easy. Sure. Where? Oh, there's like the right way to name it here. This is so annoying. No argument. Invalid index. Now is it happy? Okay. Yes. Okay. This just makes everything life a little easier. This will make stuff crash, right? And sure, we'll get to the how to handle crashes later. This will throw an exception. This causes an exception, and we'll crash the program if we don't handle it. We haven't talked about how to handle it yet. Okay. Now let's see if we can set first name and last name. All that work to get a reference. Maybe it'll work. I hit a breakpoint. Okay, that's fine. That's fine. Just continue. Did we get it? Look at that. Now we get IDs and names. So we got our references out. Fantastic. And when we get the references out, maybe I should have put that breakpoint back in. It's not calling the copy constructor because we're not making a copy. That probably would have been fine. So when we return that, right, we step, that's just it. We're done. Okay, there's no copy happening because we're passing the reference back. Okay? So, but having a copy constructor lets you make one object out of another. And that the syntax looks kind of funny there, but I could say here, if I wanted a person blowfish 2, I could then hand it the original. This calls the copy constructor here, given a reference to another one. So this is the copy constructor. This stuff it's a little dense. I know it's some real, I don't know, esoteric's not the right word there, but some next level stuff with all these constructors. But it is important. And what do you think happens when we make person blowfish 3, fish 3 equals blowfish? What happens here? Well, we get similar to what was happening before. It's a member-wise assignment. So C++ will figure this out for us and assign each one of these members to a copy. So let's put a breakpoint in here. So it's different than the copy constructor. So if we step in, let's see where we shouldn't take us anywhere. Is it taking us there? No, it's doing it. Close to the copy constructor. It's supposed to not go there. That's okay. So we can overload the member-wise assignment operator. So we can say, where is it in here? Let's do it. Where did we do all those? Oh, we did that in parent. That's why. That's where we had that one. So I can say operator equals, oh, it's a single one. So it's a person operator equals a person constant person reference person. So I can define how the assignment operator works as well. And again, it's pretty much the same thing. Works the same way. So if you don't want to do the same work twice, right? If you have this one already done, we can just do that. We can say return person giving person. This is like a shortcut. Just do the copy constructor again. So the assignment operator, in our case, is doing the exact same thing, right? It's just going to make a copy with the copy constructor. We've got our copy constructor, we've got our assignment operator. We can overload the assignment operator here. We like that. Operator. Other classes, you can overload over other operators, like how you add one class to another class, or like what would you get when you add two of them together. There's some fun examples we can do with those. We're a little short on time, so I don't think we need to bother with that one right now. Yeah, so we've got assignment operator, that's good. Okay. Yep, overloading that one. Good. Good. Copy assignments, copy constructors. Yep. Let's see. Yes, okay. Yeah, so the regular constructor, the copy constructor, and the assignment operator. I think this will work all here, right? Let's just double check and get the right one. Let's double check. What? Didn't go to that one. Why did we not get that one? Got the copy again. Where is it here? I do this again, is it? Is it this way? There's one of the ways we can trigger it. Let's try that. Oh, it doesn't like it. Must be a modifiable value. Oh, geez. That doesn't like that. Yes. A person pointer called blowfish3 equals blowfish. Is that going to do it for us? Three. Still can't assign it. Oh my goodness. The dereferenced. There we go. Let's try that. See if we get the right version here. Nope. Oh my goodness. Why is that uninitialized local variable blowfish3 is never used? Why is that making that not work? Blowfish3 get first name. Now it's gonna make my error go away. Oh, it needs memory. It needs memory. Oh, Eric. So assign that to a new person. There. Now we've allocated some memory. Now we can actually go copy those values into our new location in memory. You got no new on you? We'll get there. We'll get there. Right, so that calls the empty constructor, which calls the other constructor. Now we're going to see if we can step in. Now we get my assignment operator. Finally, okay. All right. And we're just going to do the copy thing here. Step out. Step. Copy those values over. Turn it. And now blowfish3 has some values. Uh-oh, it doesn't though. Doesn't have any values. We've lost our values. Let's go back. Step in. So we're going to make a copy of this person. So the other person we're copying here is blowfish, fugu, number 1. So we made that, and we're going to return that person here. That is my, person constructor, person variable. All right, it's not happy with that. What did we do wrong here? Is that supposed to be a reference? Maybe it's supposed to be a reference. These ones always get me. I'm sorry. Let's see. Overload? Yeah. That's right. So we need to, we need to return the, well, can we just copy it? So we need to make a person, given person. No, we just return the person, right? Return the person. New person? Yeah, the reference. It's got to be a reference. Oh, it's making another copy. So many copies, my head hurts. My head hurts. Not had enough coffee for this. Now it doesn't like that. So we are a person. Yeah, I think we. I don't know if we can copy that. We want to just copy all of our own values over. First name. Maybe that's all we need to do, because we already are a person. That's right. Okay, I was backwards here. I'm sorry. So when you do the assignment operator, like we already exist. Right? Blowfish is something. We have some person variables, but we want to make a copy of those in the assignment here. So we want to take all the values and copy them over to our current self here. That ought to do it, right? Let's take a peek. It's awkward stuff. I'm sorry, guys. Let's try it. Now Blowfish 3 has some values. There we go. Now he's a copy of Blowfish 1. Oh boy. Okay. All of this was annoying and mostly useless, right? Because we wanted... I mean, sure, the default ones don't do anything more special than what we're getting here. But where it becomes useful now, I promise it's useful, is when you have dynamic memory. If my parent class has a dynamic array of something, and we make a copy of it, let's take a look at what happens here. So let's make another parent here. So parent, we'll call this one the spouse, with 2 children. And, I don't know, or just say spouse equals parent. Let's try and assign, right? Or we can say a parent other spouse given the parent, right? To like funny copy constructor, right? Remember, C++ generates one for us. It's doing it, sure. Let's see what happens on those. And then let's go back here. Let's change Blowfish's. Oh, let's change my name for fun. So all of my kids and my wife have a J name. So they always joke around that I should be renamed Jarek. I should change my name because all 6 of the kids have J names and my wife has a J name. It's apparently a thing on her family side. Her grandfather has a J. So all of her aunts and uncles have J's. Yeah, anyway. So let's see what happens. Let's put our breakpoint down here. Nope, we don't need it in here. So I will continue. Okay, so now I've got my parent, I got my spouse, and I got my other spouse. They all have children, right? I can only see the first one here. That's the problem with using that regular pointer notation. That's fine. So now when I change parents, right, because these are copies, right, when I change parents' first name to Jarek, oh, look, they all got changed. Well, look at that. Isn't that annoying? Because the default operation here, a member-wise copy, says, oh, what is the value of children? The value of children is a memory address. So it says, sure, I'll copy your value over to a new one of these things. So if we all now point to the same location in memory, we've got multiple pointers looking at the same object, which is almost always trouble. Almost always trouble. So anytime you're dealing with dynamic memory, you should always have your own copy operator, assignment operator, copy constructor, and assignment operator. So we need to write them. So this is a parent given a constant parent reference to the other parent. Right? And I can't just say my number of my children pointer equals your children pointer, right? We need to make a copy of all of the children there. And oh boy, isn't that fun. So my children needs to be a new dynamic array given the other parent's number of children. Parent dot parent dot, come on, maybe the other parent. What? What did we do here? Why is that not giving me the other? That's the person. Oh, we have the other. Parent dot. Number of children. Why can't I do that? Alright, type ahead just hates me, I guess. So I'm going to make a new dynamic array, right, given that copies version. And then I'm going to set my number of children equal to the parent number of children. Okay, and now for index is 0, index is less than the number of children, index plus plus, we're going to loop through and we're going to make copies here. So I'm going to take my children at index, and I can assign it because I know that their class, right, has the right constructors and stuff. I can assign it the other parent's children at index, and it should make copies for me. Oh, is that going to give me a reference? That's going to give me a reference. Crap. No, that should make a copy. I think this will make a copy. Okay, so now we've got our copy constructor. We also need to do the assignment operator. Parent reference operator. Oh, whoa. What did I do? Stop. Operator equals constant parent reference parent. So this IntelliSense is just hating me today. Yeah, you always have to be careful whether or not you want copies or not. But anytime we're dealing with dynamic memory, we need to be very explicit so that we don't get that member-wise constructor or the default copy constructor that's going to say, oh, you want the value? Sure, the value is the pointer, the place in memory. We're going to get screwed, and bad stuff will happen. So now our assignment operator. So now this one is different, and we do need to be careful with this one. So I should have done this one first. It would have triggered it for me. We can't just do a copy here and assign, because what's happening here is a parent object already exists. Right? What's happening is we're modifying ourself and returning a reference to ourself here, which is awkward, but that's what we're doing. So what I need to do is I actually need to delete my children, delete the children array, to free up that memory, because I had dynamic memory allocated. Why is it not like my... I think IntelliSense just hates me today. It's delete on this side, isn't it? Nope, maybe IntelliSense is fine with me. Okay, IntelliSense is fine, it's just helping me. It's one of those nights, guys. Folks, one of those nights. Alright, so you're going to delete children first to free that up. Then I'm going to do this thing. Then I can return a dereferenced this, right? Return myself. So if you want to assign to me, great. First I'm going to free up the memory, then I'm going to copy. That make sense? So now let's try this in debug mode. Let's see what happens if we set some of these. So I see I've got parent, I've got spouse, and I've got other spouse. And I can just see right off the bat here that children here is at 764, children here is at 614, and children here is at 6 BC. So I can see they're at different memory locations. I know it's a little tiny there on the screen. Sorry, this one doesn't seem to zoom as well. But I can see they're in different memory locations. So changing this one now only changes this one, because now they have an actual copy. So that's the important rule. So building your own in a class that just has regular attributes, not really getting anything out of it. You can, if you want finer tuned control over certain things, sure, why not? Maybe we want to say, let's change the ID number, but then it's not really a copy. But maybe we always want that to change. So you've got some options here, but they're critical when you have dynamic memory. And then the other thing we're missing, hopefully you noticed, right, is we're missing our Destructor. So we also need to tell C++ how to get rid of one of ourselves. And remember, that's the tilde character, that's the shift backtick, like right above the tab key usually. Parent. And that has no arguments ever, and we just call the delete children. Need to free this up, because we're not using smart pointers, because we're not smart. We should just use smart pointers. But that's okay. But we're going to look at it the hard way so you can appreciate it. Whew, it's 7:10 already. You guys have been sitting through all of this. Your heads are probably spinning. I apologize. It's going to take a little while for this to go through. But so pretty much anytime you use dynamic memory, you should have a Destructor, copy, constructor, and assignment operator. So that's somewhat, or sometimes referred to as like the rule of three. If you have any one of them, you should have all three of them. Like if you need to destruct something, you probably also need to know how to copy it and assign it the right way. They do reference that somewhere in the book here, that we should probably do them all at a time. Where is it here? Yeah, you should define all. There is also a move. We're not going to worry about that one. So don't worry too much about the move one here. Okay, so if you have any of them, you should have all of them. And typically that's what we know we need it when we're dealing with dynamic memory, because we need to make sure we're not blowing anything up or having duplicate references, you know, two different pointers pointed at the same location in memory. Okay, so why don't we take a little break? We'll come back in a little bit. We got a couple more topics to cover here. A little bit more around design, and then inheritance as well. We'll cover that other core topic of object-oriented programming. And then we can call it a night. Hopefully we'll finish up about 8 o'clock or so. I'll try and finish early if I can. So why don't we take a break, come back at 7:23 or so. Let me put this up here. I think we're done with the ads. Oh, I forgot. It's just been playing the whole time. It needs to be unmuted. Maybe I hit the unmute button. Unmute. Maybe. Yeah. Vectors are so much better. And doing our own copy, yeah. Come on, unmute. There it goes. Sorry if that blasted your ears. I'm just going to rewind it here. We need a few minutes. So we will come back. Let's see. Nope. How about 7:23? All right. Be back in a little bit. You guys get your coffee. I'll see you soon.
I just got this voice changer for $5 to tell you about Taco Bell's Grande Stacker Box. Stacks of melted cheese and seasoned beef, plus 2 crunchy tacos and a medium drink for only $5.
Oh man, those ads are getting funnier. Sorry about that. Hey guys, let me get that muted here. Flip back over. Alrighty, let's see. If that stops, I'll just pause it when the music's here. Nope, more ads. Okay, I'll let the ads run for a minute. So, how you guys doing? I know it's a little crazy. It'll take some practice. The main idea here is that if we're using our dynamic memory, we need destructors, copy constructors, and assignment operators to make sure that we're doing the right thing here with our dynamic memory. So we don't have memory leaks and we don't have duplicate pointers pointed at the same thing. It takes some practice, as I was demonstrating on purpose for you guys. The syntax is hard, and it's likely to get screwy. Thanks, man. And it'll just take a little bit of going back and forth before you get familiar with it. Oh, 1 second, sorry. Alright, did not get a chance to get dinner yet. The toddler was a little sad. He's a big daddy's boy. But I did get some breadsticks microwaved, so I will eat those in a minute. Alright, the next piece here that we want to look at is this idea of inheritance. So the book talks a little bit about this idea of class aggregation or composition. That sort of idea is it's a has a. And we did that a little bit here with parent. Like parent has a or has children. It's not, parent is not a child or a person. I guess it is as well, but we sort of forgot that, but it's okay. But it has this other class. So one class can have members of another class. That's fine. The next thing that we're going to do when we look at inheritance is creating an is a relationship. We'll say that this class is a type of this other one. So person's great, right? It's got some information, first name, last name, ID number here, but maybe we also want to do more with it. Now, there's debates on whether or not how useful this is, but if we write a class and it's wonderful and fantastic, we use it all sorts of places, you probably don't want to change that class all that often and add more stuff to it, right? Because it's used so many other places and you'll have so many downstream effects. And person is probably fine as is because that's the way we designed it. It should do the right things. But what we could do is if we really need a person, but then we also need to track some more information. So maybe we had to represent a student. If we write a class for student, actually, I gotta make this low down, right? Lower. So let's write a class for student. And well, student really, I don't want to have to duplicate all the person things. And sure, it's silly. First name, last name, ID number, whatever. But I don't want to have to reinvent the wheel, right? I'm a nice, lazy programmer and says, oh, we already have a great person class that does these things, but I just need some additional features. What we can do is we can extend the functionality. So we're going to write a class student here that's going to extend person. So we say, okay, a student is a person, and this access modifier here we'll get to. Public is probably fine in most cases, but you can get specific if you want to about how you do that sort of stuff. So now here we're saying that a student is a person. So a couple different names you might hear for this. You might hear that this is the superclass and this is the subclass. You might hear that this is the base class and this is the derived class. You might hear that this is the child class and this is the parent class. They're all correct, right? So maybe we'll put all those in here. So the subclass, child class, derived class, subclass, get all these in here, subclass, child class, derived class, sure, are all names for the first one. They is a of the base class, the parent class, or the super class. Oh, I'm in the wrong order here. Let's do it in the right order. So typically the pairs go together, base and super, or super and sub, derived and base class, or child and parent class. Everyone, whatever terms you want to use for it, great. They're all the same thing here. So it creates this is a relationship. That's the important part here. So a student is a person. So what that means is we do all of the things that a person does. So that's all I do right now, and I just extend it. Now I can come over here and I can make a student. I don't know, we'll call just student here, and sure, make a student. Now student dot, and I get all of student dot. Hates me today. It just hates me today. Student dot. Oh my goodness. Why are you not working? Should be able to see it here in a second. It's just being super cranky with me. Don't know why. Maybe. Student. Yeah, it's Visual Studio just upset with me here. So I don't even see it. Student. What? It like didn't even compile it here. I don't even have an argument. A variable. I think I just need to reboot. That'll stop the stream. Student. Oh my goodness. Oh. What did I do wrong here? Maybe it just wants something in here? Sure. Public student. We'll just make it constructor. Just, I don't know. I'm hoping it builds. Student. Student dot. Has a class type. Class student. It knows that's a class student. It knows it is. All right, I'm going to just nuke this real quick. So you have this option for clean solution. And clean, like, it's not uncompiles, that's the wrong term for it, but it blows away all the stuff that was compiled and built. And kind of cleans it all out. And now I'm going to see if I can just do a fresh build. Maybe I've got an error and it's just not telling me. Nope, no errors. No errors there. So student dot. Some student. Maybe he doesn't like the name shadowing. Some student. Nope. All right, guys. Let's try option 2. Close Visual Studio. Oh, I had something running behind the scenes. I wonder if that was why. Let's open Visual Studio back up. All right, and while that waits, I'm going to put myself on mute here, and I'm going to eat. Blowfish, if I haven't said it before, you're such a saint for sitting through all this with us. That is awesome. Appreciate you hanging out with us here. Now I'm going to cough and blow your ears. Oh man, don't take a giant bite of day-old cheesy bread and then like try and swallow it really fast. Some student, come on. Like it's not even recognizing it. I broke it. I broke it real good. It should all be here. Person. The type of person. There we go. So I can at least show you here, because sure, we can do that. I have access to get first name, get ID number, get last name, set first name, set last name, operator equals. I have access to these because I am a person. So when you do this inheritance thing, you create one of these relationships, you are one of those classes, and you'll have all the attributes. Now, you notice the attributes are private in person, right, which is usually our good practice here. So as an inherited version of person, I have no access to them because they're private. Only the person class itself can touch them. Now there is another level of access that you can declare called protected. Protected is essentially private, but what it lets you do is have access to these things in inherited classes. So if I change this private to protected here, now when I come down, I should see in my this pointer, I should get access to everything. Now I get these here. Now they're kind of starred there for you, which is cool. It's telling you, hey, it belongs to person. So you can see it there. That's this little protected person first name thing. But I have access to it because protected is a level between private and public, which in your inherited classes can have access to it. So if you want to be designed in such a way that your inherited classes have full access to your attributes, great, mark them protected. If you don't want them to touch them at all, mark them as private. So, sure, that's it's up to you. So my this dot, right? Sure. Let's say I want to now use my constructor. Right. So what's going to happen is I need to call my parent class's constructor. So if I want a no argument constructor, great. But if I want a argument constructor that takes a string for first name, a string for last name, and say, I don't know what else, we're going to have some private attributes here too, right? So we'll have, so what's different about a student? Well, a student probably has a GPA, which is a double, and they probably have a string for your major, sure, okay. So I'll take first name, last name, and then I'll take a string for major in a constructor. Then what I can do here is I can say, okay, sure, I'm going to give that to person. So just like the member-wise, the member assignment stuff you could do, like when we looked at person, we could say, hey, assign first name the value of first name, assign last name the value of last name. It's that same looking syntax. We're going to say, okay, hey, person constructor, take my first name and last name. Boom, have them. Okay, then I can, oops, wow, too many curly braces, sorry. Then I can take my this major equals the major, and I can take my GPA, and it probably starts off at 0, right, until you actually take some classes, right? And really, GPA, that's not actually what we want to do. We want to have like total possible grade points, and we want to have a earned grade points. And that's how you kind of calculate that, right? Because you're going to take your total possible grade points divided by how many you earned. So really GPA is wrong. So we want total possible is 0, and we want earned to be 0. And then to calculate GPA, maybe we make this a double method here. Get GPA, so like that, right? Grade point average, right? Remember, to get an average, you sum them all together, divided by the total. So it's earned divided by total. We can just return that, right? That's calculatable. And then we probably need a way to earn grade points, right? So probably a void method for like earn grade points. That probably takes a double for earned points and a double for possible points. Because if you just divide by 0, bad stuff happens, right? Actually, I think that won't even crash because we're doing doubles. You'll get like not a number or infinity or negative infinity. You'll get some crazy stuff, right? C++ lets us do weird things. But when we earn grade points, we're going to take our total possible. We're going to add in the possible points. And we're going to take the earned, and we're going to add in the earned points. Earned points. right? So as you earn grade points, right, we'll be able to calculate the GPA. So if you get an A, you get 4 earned points out of 4 possible points. A B plus is 3.7 points out of an earned possible 4 points, right? A B is 3, is that right? B minus? Wow, I should, okay, let's look that up. Oakland CC grade points. Something like that. I think we'll be able to find it here, right? Grading policy, there we go. Oh, A minus is 3.7. That's right. A B plus is 3.3. Okay, forgot A minus. Right? So that's the total possible, right? And this is the earned. You know what? That's not even right, is it either? Because it is also by credit. Right? Because a 4 credit A will weigh more than a 3 credit A. So what you actually get, so a 4 credit class, it's out of 16 possible points. And the grade points you earn is 4 times 3.7. Right? Does that ring any bells for you guys? You're all smart folks. You know how to calculate GPAs. Multiplying credit hours of individual courses completed by the grade received in those individual courses, adding up those totals. Grade points are then divided by the total credit hours completed to yield the grade point average. Oh yeah, no, I screwed that up. Yep, so I'm doing the wrong thing. Because you divide it by the total credits, not the possible points. Man, okay, look at that. This is good. Those are earned grade points, and we have total credits. Okay, so let's fix it. Total credits, total credits, total credits, divided by total credits, total credits. Or if we're shadowing, right? This total credits, and maybe that's just credits, credit hours. Yeah, okay. I'm gonna rename this. So refactor rename, right? Don't do it by hand. Go to rename, total credit hours, and apply. Right, it's gonna change it for you. We like that. Let the tool do its job. Okay, so now the earned grade points divided by the total credit hours should give us the right GPA. So student is a person, but now it can do additional things. Again, the things person does are kind of silly, but that's just our basic example, right? I don't have to reinvent the wheel for any of that. So I'm just going to say, oh, here, constructor, go for it. So if I give it no arguments, right? If I essentially don't have a major, right? Well, I really just want to call student, I guess, with no name, and no major. Right, why not? Sure. And maybe we'll have a get major sort of thing, a string for get major, turns the major, and we probably want to be able to change your major, right? Have you guys ever done that before? Maybe, some of you. Avoid set major. That should take a string for major. Typing too fast, sorry. Trying to get through this. String for major. I'll set my this major to the major argument provided. Okay, cool. So now you can change majors. Maybe now student will do something. Some student. It does not know what it is. What did I do wrong? That is insane. End line. Like, and it totally is skipping over. Let's just put it up higher. Any luck if I move it? Some student? Nope. It has no idea what a some student is. Wow. Student. Oh, it knows the type. ASDF. Oh, maybe I should try it again. Student. Student dot. Hey, no one knows what a student is. Student. It's the stupid constructor. Oh no, that's why. Because I was using the constructor. All right, Eric, Charnesky, CIS. Now I can student dot. It was the constructor, Blowfish. I blame you. I blame you for not finding it. I was totally relying on you to find my errors, and you weren't there for me, man. I'm gonna have to dock your pay. Is that okay? Can we take away some of your bonus points? Blowfish isn't in the class, by the way, if you guys didn't know that. It's just a friend. So now I can call student dot what, earn grade points? Sure, let's say I got 16 grade points out of 4 credits. And then I'll see out GPA for student.get first name, colon, I guess we don't need a colon before my name, do we? Student.get GPA, and then mine. Awesome, let's see if I get a 4.0. Right, if I got 16 grade points out of 4 credits, it should be a 4.0, if I did my math right. I was thinking way hard about that. And interestingly, now you notice 1 and 2 are the IDs for the other people we make. Because student is a person, that person constructor is getting called, right? And those are adding up and counting and moving up. So we get 1, 2. Oh, how did the next Eric get 4? Oh, because we did a copy. So we got 3. Look at that fun stuff. My GPA is 4. Awesome. All right, how you guys feeling? I know this was a little nuts. Other things you can do with inheritance. In this case, I don't think we've got any good reason to here. Let's see, what does person do? Person. Yes. Okay, so those are all boring. If you wanted to, right, what you can do is you can override the behavior of your parent class's function. So what that means, sorry, that's not really a good, what functions do we have? Sure, let's change get ID number. Why not? Get ID number. To indicate that you're a student, let's do that. We'll say I want to have an int for get ID number here. So I want to change the behavior of get ID number. So if it's the same signature, remember the signature is not actually the return type. But what we're going to do is we're going to change the behavior of this get ID number. Get ID number, right? Get ID number. Okay. So this is overriding, not overloading. So we want to return, say, what should we just do? We should, it's silly here, but that's fine. We're going to return, let's add 1,000 plus this get ID number. I'm just going to add 1,000. I don't know why. Overrides the parent class behavior. Ooh, and actually, no, this is wrong. I'm sorry. If I need my parent's version, I need person get ID number. Because I actually want the person version. If I called this, I'm going to get this one again. I've got an infinite loop. We would have just done a bad thing. All right, so let's see if we can get ID number out. See out ID number for student. Student.get ID number. Student get ID number. Great, and then line. So let's put a breakpoint in here. We're going to watch it happen, which is pretty fun. So that's the other piece. If you're customizing, right, adding additional features to that parent class, right, saying, okay, I like everything you do, but I want to do a little bit more without changing the original, you can override behavior. And now we'll get a different version here. Didn't I click run? There we go. And in debug mode, we can watch it step through, which is really fun. Okay, so I want to step into that one. Is it going to let me? Yes. So now I'm at get ID number. Right, this here, right, is a person. Oh, what is first name is? It looks like garbage here. Garbage. That's not cool. What do we do? There we go. Okay, I had to finish getting into the method here for it to all load and actually read all that stuff out. All right, so now the ID number inside of person is 0, so we should add 1,000 to that. Oh, I meant to step into, sorry. Let's step into that. Step into. Now we see it jumps up to person, get ID number. And now this here is limited to person, because as far as this code is concerned, it only knows that it's a person. But it's using the person class that we've inherited from. So we're going to return that ID number. Then we're going to return that plus 1,000, because why not? Because we're students. And we'll output it all. So you can override that behavior. So this is overriding the parent class behavior. Now the other thing you need to do, which is another reason to use pointers, which is really cool, is I can do this really crazy thing here. I can say, hey, I want a pointer to person. We'll call them Eric. Oh no, this is Eric student. And we can say, hey, it equals the student. Student, is it the reference to student? There we go. Reference to student. Now this is crazy. This is saying a pointer to person is the student. Now, a student is a person, so technically this works, right? But now what happens is in Eric student, right, when I use these functions here, I guess we didn't, all of the get GPA stuff goes away because my pointer isn't treating it like a student, it's treating it like a person. But here's the magic. Here's the magic part here. I can call get ID number. Let's see out the pointer to student as a person, get ID. End line. Okay, what ID do you think we're going to get here? It's a trick question, don't worry. Here's the real magic, and here's really why pointers are amazing. And we have to spend a lot of time dealing with pointers. So if I step in, I'm getting person's ID number. Well, crap. That's not the right number. I don't want 0. 0 is not what I wanted. Or 1, sure. It's the next person. That's bad. Here's the magic part. What you can do, when you define the function here, if we define it and we add this cool keyword called virtual here. So virtual indicates that it is meant to be overridden, or meant to be, or allowed to be. Yep, virtual. And then down here, when I go declare it, what's going on here? That's fine. That's fine. Where's my get ID number? Over here. We say override. Nope. Is it override? No. I got the wrong keyword. What's the keyword? Virtual. All right, let me just go Google it here. Plus virtual override. Let's find some decent functions. Stack Overflow usually has some pretty good hits. Yeah, override. The override keyword. Virtual. Yeah. Virtual. What? Is it not the override keyword? I'm going crazy here, folks. Is it over here? Override. Is that really? After? That looks funny. But let's see if it does it. Let's see if that works. That looks really crazy. Why is it doing that? So we're going to see, I've got my pointer, right? It's a reference to student. So Eric's student, as far as we know, right, we only had access to the student attributes. but it also, I'm sorry, it only had access to the person attributes, but it knows it's actually a student, and it knows it has these other attributes. So now when I step in, because we've marked the function as virtual, I'm allowed to override it. Maybe that keyword's not needed, but you see now it's taken me to the overrided behavior here. We're going to get the correct ID number out. Maybe it's just virtual. Let's try that again. Let's try virtual. Let's see. Override. Let's try that. I think you need to override. You definitely need virtual in the parent class. Let's see. We'll step in. Now look at that, we don't even need the override. Okay, cool. So if it's marked as virtual, what it lets you do is when you have a pointer, so when using a pointer to a type of base class that is actually a derived class. Methods marked as virtual will run the overridden behavior. Does that make sense? This idea that if I marked it as virtual there, what it does is it gives me the overridden behavior. And that has a technical term for you, by the way. That is called polymorphism. Another one of the core concepts of object-oriented programming. Kind of goes hand in hand with inheritance. The idea with inheritance is you can create is-a relationships and expand on the functionality of classes. You can customize them, right? We need to add some features. We don't want to change the original. I want to customize it. Great. I don't want to have to reinvent the wheel. Someone wrote a class. It's fantastic. It's wonderful. I don't want to have to change that. I just want to tweak it. Great. I want to add additional stuff. If the method is marked as virtual, then the parent type, if it's a pointer, and this only works with pointers, we can get that overridden behavior on the overridden functions. Now I still can't get at Eric student. I still can't get at the student functions here. I still only get the person functions. But any person function that's been overridden now will automatically give me that, they call it polymorphic behavior. So polymorphism means I can treat one type as another, like to polymorph, to change forms. So I can treat what is the child class as the parent class, and I still get the right functionality. It's amazing, and this is like real magic that happens because it knows that it's referencing something that is custom to the original. Not actually a person. It is a person, but it's a modified version of person, and it will do the right modified behaviors, which is super cool. And we can't do that without pointers. So it's another reason pointers are so helpful and so useful. Okay, so I know this was a lot. We're going to keep practicing it as we go. Our next project will deal with inheritance. I'm not going to bother throwing all this dynamic memory stuff at you where we need these copy constructors and assignment constructors and operators, because that can be a big hassle. And that's a little bit more advanced anyway for an intro to C++ class, but just know that they exist and that you need to do them if you're using dynamic memory. So we just won't have an assignment that uses it. We'll be okay. We'll do something with inheritance. So this is a relationship type. And you can inherit a class that inherits from a class that inherits from a class that inherits from a class as much as you want. You can go nuts here. Now at some point, that's just bad form, right? Because you've just made some giant tangled mess out of things, and really the code here is for people. Right? The reason we have all of these features is for people, because we do have those is-a relationships in the real world, right? A student really is a person, but it's like a special type of person, right, with additional information about them. I could have a different subclass of person for faculty, right, or professor, right? They are a person. I promise you, I'm a real person, but they're a different type of person. They have different information that we need to store about them, that sort of thing. So it lets us not reinvent the wheel, right? Which is one of the goals of having classes, of being object-oriented. Not only does it make it easier to talk about, easier to design and consider and work with, but now we can take advantage of this polymorphic behavior, this inheritance stuff, dealing with an abstract class, right, where you only need to know the public interface. All the details are encapsulated away inside the class. It hides all the private stuff away so you don't have access to it. You interact with it through its public API abstractly. Right? They kind of all link together here, but they all work together to make sure that we have an easier to read, understand, follow, and write code base. Because the code's for us. Right? The computer could care less. The code is for us to read and understand and follow. And the minute it starts getting confusing is when we've probably gone too far. So just because you can inherit and inherit and inherit and inherit and inherit doesn't always mean you should. Right? So just again, that's the art piece of this. It's not just a pure science. As much as I love computer science, right? It really is an art to doing good software engineering. Okay, so let me push this all to GitHub for you guys. We've got another 2 hours or so of class left. This is chapter 11 examples. Please do go read the textbook. Like, I'm trying to pull out the highlights for you, but if the only thing you ever do is listen to me, you're missing so much. Right? We've got a good textbook. Let's use it. So go through, look at the examples, try some of his things. Right? The only way you're going to get better at coding is by actually writing code. There we go, push. So try some. Above and beyond the projects, if you've got the time, you'll get a lot more out of it, and you'll get better at it a lot faster. And don't feel bad if you don't know how things work, right? And you need to go Google a bunch. That's okay. Just know specifically what you're trying to Google for, because you can go down some rabbit holes that are just crazy, especially with C++. It's been around a long time. You can do a lot of things with it. It's super powerful. So the textbook should be a good resource. I'm trying to give you some examples that are just illustrations of these features. And we can go from there. All right, so do take the midterm. It's due by 10 in the morning. Right, it's got the 2-hour time limit on it. If you run into trouble, contact me as soon as you can. Right, the technical trouble, contact the Desire to Learn help desk, and then loop me in so I know you were having trouble. If you wait until tomorrow at in the afternoon and say, "Oh, I had trouble yesterday," or "I had trouble last night, I need to redo it," I'm going to be a little bit upset because you didn't tell me right away. Okay. Open book, open notes, open sources online does not mean you can discuss it with people online. Right? The resources that are available online, and Chegg does not count. Chegg is a terrible website. They're full of terrible people who help people cheat. I despise Chegg very much. So don't cheat. Right? Remember our academic integrity policy. If you cheat, you fail the class, get reported to the dean's office, bad stuff happens. It makes me do a lot of paperwork and it upsets me greatly. Right? So turn in your own work, please. All right? If you find a source, cite it. Just drop a comment in and say, "Hey, I found an example here." Okay? All right, I think that's all I got for you guys tonight. Do you want to see who else is out there in the Twitch universe? If we want to go raid somebody for fun? We got a small crowd here still, if we can find somebody. Make sure this gets muted here, though. Let's see. Come on, it's loading real slow. Maybe it's loading. It might not be loading at all. All right. Let's see who's on. What, show me that. It's small and I don't get my list of follow channels. Show me the list of channels. There we go. We did we raid the psych prof? Yeah, our psychology prof last time. We did him. You want chess? Just some fun chess hanging out. Or there's Skylius. She talks about astronomy, space stuff, rockets, I think. What do you guys think? There's also, who's that? Touring news. If you're interested in news, we also got news. That might be fun as well. What do you guys think? Or we can just bail. Totally up to you guys. Astronomy. All right, let's go try. See if I can raid her channels. First vote wins. Let's try it. Yeah. All right. Let's go hang out over there. You guys take care. I'll be in Discord. Have fun with the midterm. We got 6 seconds, 5 seconds. There we go. All right. We'll go over and say hi. Oh boy, there goes my phone. See you guys.